Our program today is on the GE Panametrics PT878. In today's program, we are going to talk about measuring flow, basic programming, sensor installation, measuring temperature, logging and retrieving data. Well, for those who do not know how an ultrasonic flow meter works, a quick analogy is the story of the man in the rowboat. And as you see, the flow is going from the left to the right in this river, and the man would like to cross the river, and as he crosses the river he's carried downstream and it takes him a certain period of time. But as he comes back across the river, he meets the current and it takes him a longer period of time. So there's a differential in his transit time across the river versus his transit time coming back across the river. And that differential of that transit time is how we calculate how fast the river is flowing. And in this case, how fast the flow is flowing inside a pipe. We have a bird's eye view here and of this pipe, and the same analogy is as opposed to going across the river here, we're going to ricochet it off this back wall. So we got a bird's eye view, we're looking down from the top. The sensor on the left will send a sound burst across the pipe, ricochet off the back wall, come downstream. We're going to measure how long it took to do that. The sensor on the right hand side will send a sound burst across the pipe, ricochet off the back wall, but remember the flow is going from left to right. It will take a longer period of time. The greater the differential, the faster the flow rate. So again, the same type of functionality, and we have different configurations. The picture in the lower right hand corner is the man in the rowboat, and which is referred to as the Z, or the single path for the GE products, and the one in the upper right hand corner is referred to as the dual path, or the V configuration, and they're usually relegated based upon pipe size. The V configuration, or the dual path, is the most common methodology just because it's easier to do. The track's on the same side of the pipe. You can see both transducers, and it's usually relegated to pipe size. So for example, the one in the upper right hand corner is traditionally used in applications that are pipe sizes, say 2 inches up to 24 inches. And the one in the lower right hand corner is traditionally used for larger pipe sizes, say 24 inches, or it's also used in applications that have less than the normal straight run of pipe, and smaller pipe sizes, or pipes that are in poor condition. You know, your 50 to 100-year-old crusty old pipe that you need a little extra sound. So you can use the single path configuration for smaller pipe sizes applications there, but it's usually warranted for larger. It's a little bit difficult to do, and you can get into some trouble. You can have too much power on a small pipe. So V configuration up to 24 inches. Above that, consider the single path configuration. Now, all technologies require some straight run of pipe, and this is no different. For optimum performance, what you need on the left hand side is called the symmetrical flow profile. And a symmetrical flow profile is basically where the flow is the fastest in the center and the slowest near the pipe wall. And this scenario traditionally exists in applications that you have your 10 to 15 pipe diameters. So say I had an elbow to the left here, I'd have 10 pipe diameters, I'd put my sensor here, and then I'd have another 5 diameters to the next elbow. In a symmetrical flow profiles, I said the flow is at the fastest in the center, slowest to the pipe wall. These different shapes are referred to as Reynolds numbers. Whether they're more blunt or elliptical doesn't make that much difference to us, but what does make difference to us is that if you draw a center line down this pipe, the top half of flow would equal the bottom half of flow. So in that case there, symmetrical flow profile, which in this particular diagram in your 10 to 5 or 15 pipe diameters, is also based upon flow rates that are around 10 feet per second in velocity. Higher flow rates, more straight run of pipe. Lower flow rates, less straight run of pipe. The picture to the right is on this asymmetrical flow profile. And this is basically what happens when you don't have enough straight run of pipe. So flow going up the elbow here, you notice there's a shorter distance on the inside, a longer distance on the outside. The flow will tumble inside the pipe there, and right after the elbow you will get a lot of disruption there. So if you were to put your ultrasonic transit time meter right there, you probably wouldn't get a very good flow rate. In fact, you'd probably get a fault condition. You wouldn't get anything at all. You're supposed to move downstream 10 pipe diameters, put your sensor there, because then down there it'll look like a symmetrical flow profile. So here's just as an example of this is a traditional flow profile where you have straight run of pipe and everything's perfect, and we know in advance mathematically where the transducers are supposed to be. So basically, if you program your meter, you got the pipe size, you got the process liquid, it says the transducers are this far apart, plug them right there, and when you get a signal, everything works to your optimum performance. But if you have less than straight run of pipe, you get a disruption in the flow profile, and guess what? It may actually askew where the exit point of the signal would be. So that being the case there, your transducer may not even pick up the signal. And so if you have to find the signal, you may actually have to move the transducer up or downstream in a prospecting fashion to find the signal. But once you do that, you may get a signal, but it will not be at your optimum accuracy. Same thing when you get more disruption and you have an application with short run of pipe with a variable flow rate. So the flow goes up and down, so the mean velocities move all over around side the pipe. So in this case there, you may come out to the pipe on Monday morning with low flow rates, have to move the sensor here, you get a reading, then come out the afternoon and the flow rates are higher, you may have to move the sensor again to actually pick up the signal. So again, here's a bad application. When you see something like this, the only thing that you can do is go upstream or downstream. And there are some applications you may actually have to take the old backhoe out to actually find a good installation point. And on a good application, you may actually require a ladder or scaffolding, and you have to remove insulation. So good applications may require some work as well. An interesting application, if you go to a big box store and look up, you'll see gorgeous plumbing across the ceiling with these pretty connectors on there with their quick attach, and they're basically clean up the whole hydraulic situation. And they do a very good job hydraulically, except the installation point of these devices, some of them using a thinner wall, pipe wall material here, require that the end of the pipe be ferruled, for a bad description like an ice cream cone, to adapt to these fittings. That will cause you additional disruption. So with something like that, we just talked about the 10 to 15 pipe diameters. This is considered a major disruption when you see these big connectors here. You're going to have to double your distance to go downstream to actually get the device to work. Of course, this will work on anything on cooling tower applications in the boiler room, the chiller data center, and we really get down to it. The whole purpose of monitoring flow for the most part is going to be for pump performance. So regardless of your environment, that's really pretty much what the technology is used for. We got a full pipe of liquid and we're monitoring it, and so you can have a tight situation like you see there before, or you can have lots of straight run of pipe. And then the process liquid itself will vary, everything from a clean liquid to a wastewater application. And generically speaking, an ultrasonic transit time flow meter will work on ultra pure liquids like DI water or jet fuel with a specific gravity of 0.4. I mean, really clean stuff, to water and glycol, work in sewage, but it's not going to work in sludge. So depending on the manufacturer, the generic numbers are from ultra pure to around 2% suspended solids by volume. So again, water, sewage, but not oatmeal. How's that? Oatmeal, we use an ultrasonic Doppler flow meter. So as I said, the technology, energy management, HVAC, chemical process, water in the wastewater, irrigation. So any closed full pipe, any aqueous liquid application is ideal for the PT878. Now the PT878 has been around for a long time, pretty much an industry standard in the world of ultrasonic transit time portable flow meters. Comes as a handheld device with a carrying strap, keep you from dropping the device there. It has a rubber boot on it, keypad on the front, and on the top is where all your ports come in. Your transducers will come in, your IP will come in, your power will come in, and you also have an IR sensor. This is an infrared sensor which you can download your data. It has a host of different transducers. Some of the more popular ones and the newer designs are the 402, which is a 1 megahertz sensor, which is traditionally used from say 2 to 26 inches. It can go a little higher, it can't go a little lower. The 401 is a half megahertz transducer. Again, it's designed primarily for larger pipe applications. Again, you can go to lower pipe applications if you say have heavier solids or poorer pipe wall conditions. And then the small pipe sensors, the 408 is on its own little track, which is a nice small little footprint. Off the top of my head, it's only got like a 6 or 8 inch footprint, so it's really good if you're in an HVAC application close to the coil that you don't have a lot of straight run of pipe. So you need a smaller footprint there. And it's designed as a 4 megahertz transducer to go from about half an inch to 2-inch pipe sizes. Then we get in some of the specialty transducers, another small pipe sensor that we have high temperature. And this guy will go up to the CFLP series, will go up to 450 degrees. And even higher than that, well, that hockey stick to your right there, this technology has been around for a long time. It's called a waveguide, and basically it's a heat sink. And the sensor, the transducer, goes on the end of this heat sink and basically dissipating the heat sink. And you can go up to temperatures as high as 750 degrees, but it is not inexpensive. The interface between the blade and the pipe will use metal foil, and depending upon the application, you can use gold and all kinds of other materials. So as you can imagine, the moving this sensor around can be quite expensive there, but I don't think you're going to find a 750 degrees temperature every day, but is a solution with your existing technology if you add this feature. The good old standard clamp fixture comes in different package sizes. The comes in the 12, 24, and larger. Just a hint, the 12-inch rulers fit in your carrying case. Any ruler larger than that does not fit in your carrying case. That's why we sell spare rulers. Larger applications, if you've got a lot of big magnetic or a lot of big metal pipe applications, the magnetic clamp is a nice tool, but mind you, it is the same standard clamp fixture with another, I don't know, 8 to 12 inches on either side holding the magnet, so it is a big transducer. But if you got a lot of, 24-inch pipes that you're walking around, you're going pipe to pipe, it'd be a nice tool. It has an optional carrying bag, but do take note that the maximum temperature of the magnets, I believe, is 140 degrees F. Now, changes in the midst. The PT878, as I said, been around for a long time. This year and a little bit before, they added a new part matrix. You can get, we sell them as a kit, so you'll see kit numbers on the website, and that's been going on for years. But in addition to that, you'll see on the GE data sheets the PT system part number package. And just as a quick breakdown, there is you can get the meter itself, or you can get the meter with the transducers and so on. And the reason being for this packaging is it has new discounted pricing available. So if you're interested in getting a kit, take a look at the PT Systems packages. They don't come with a thickness gauge like they used to, and they don't come with the IR reader or things like that. If you look down on the bottom there, Instruments Direct has some value packages there, and there's a small typo there. With all our systems, we include a free calibration certificate and a free USB to IR converter, not the IO cable. So those come standardly with all Instruments Direct systems. So check out the PT Systems part matrix on the website. All right, to get this started here, we need to go to the measurement screen. We consider that the home screen, and it has a programmable screen that you can, an interface, GUI interface that you can move things around to your convenience there. So to navigate to the various screens and functions of the PT878, you start off by pressing the menu button, and this will toggle the menu navigation header to the top of the screen. And from there, navigate using the arrow keys and press enter to confirm. To toggle off the menu header, press menu again. Now, another useful feature of the measurement screen is the quick diagnostic feature. Now, basically, if the meter reads and gets your flow, you're done. You're never going to use the diagnostics. If you have an application that's not working, that's when you call support. That's when we'll say, let's take a look at your diagnostics. And the most important thing you're going to look at the diagnostics would be the signal strength for the upstream and the downstream. That's another place to look at if you have an exotic liquid. So that's the first place to go should you have a problem in monitoring your flow. So to access the diagnostic quick menu, press F2, the soft key, in the measurement screen. So now we're going to go to the transducer menu. We select F1 soft key for transducers. And this is what you're going to have to do each time you change your hardware. And from here, it's divided up in a bunch of different tabs there. And in this case there, we've selected a clamp on transducer. And from the transducer menu has a host of drop-down screens selecting your type of transducer. So this is important that you put down the correct transducer, and some of the old numbers there, the 24 and so on, those are older part numbers. And you'll know you'll have an older PT878 if you don't have the firmware that supports some of the newer transducers such as the 401, the 402, and the 408. And we can update the firmware for you, or you can try to do that yourself. So you select the correct transducer, and then after that we're going to go to the pipe tab. And this is where people make their biggest mistake. Bad data in, bad data out. So you must put in the correct pipe OD, and if you're not really sure, take your tape measure, wrap it around, divide it by pi 3.14, and you'll have your pipe OD. You can flip the ANSI switch there and put a nominal pipe size in there, which can help you, but you got to put in the right pipe data in order to have this thing calculate properly. The next tab is lining, and the only time you're going to see that maybe is in a municipal application where you get a cast iron with a mortar lining or a ductile iron with a mortar lining there. Occasionally in the industrial side you'll see some Kynar linings and so on. But if you have a liner, you have to compensate for that as well. Now we select the liquid. So we go to the fluid tab. It's a drop-down menu of all the different processed liquids. It will automatically default the sound speed for you. If you have a unique temperature situation, there's a place to plug in the temperature on the lower corner of the display itself. For the most part, the device here is probably plus or minus 10% of the sound speed, and you're really not going to have any significant differences. In the case where you have your HVAC application, we have water and glycol. You can see the bottom lower right hand corner. You can actually plop in your 30% glycol, which is traditional. But as you'll note, as I said, the generic rule is plus or minus 10% of the sound speed. It doesn't make a whole lot of difference. If you look at the difference in sound speed of water and 30% glycol at nominal temperatures, you're not going to be outside that 10%. So in a lot of cases, you can just leave the meter set up on water and get correct data. Now we're going to select the path. So on the path there, remember again, we were going to select a single traverse, which is a Z mount, one on each side, or the V mount configuration, which is both on the same side. Again, most of you will be using the two traverse, which is the V mount configuration. And then the device will give you the spacing and where to locate the transducers. As we said, you want your 10 to 15 pipe diameters downstream. More if you have obstructions like we looked at before. Get away from those special connections, get away from pumps, get away from T's, reducers, and any invasive thing inside your pipe. Now we get to the transducer itself, and the most common question people ask me is, geez, how much goop do I put on the transducer? How much acoustic coupling do I put on the transducer? The rule of thumb is like toothpaste on a toothbrush, and the type of couplant that you use is also indicative of your application. So some of the GE kits standardize on using the water-soluble grease, which is great. You can clean up and wipe up, and your hands aren't too yucky when you're done there. But it's not going to tolerate a moist liquid application when you got sweating pipes, or cold pipes, or hot pipes. So then you're going to have to use a silicone grease. So we have a host of different couplants you can use for different applications. Toothpaste on a toothbrush is usually all you need. The transducer is flat, the pipe is round. Sound travels faster through a solid, hence the acoustic couplant is the solid that transfers the sound through. You need to prep your pipe, so if you have insulation on the pipe, you cut a complete horizontal cut and remove the insulation off the outside of the pipe. We get calls from people all the time, so they have a problem, and basically they're doing the cookie cutter outfit. They'll go to the insulation, they'll cut a little hole and stick their sensor in the little hole and never get the spacing quite right, and secondly, never really discover what's under the insulation. There's always a surprise there, so if it's at all practical, you got to remove the insulation to put the sensor on the pipe. Adjust the sensor spacing, strap it to the pipe, and you're good to go. As far as location on the pipe, vertical, horizontal doesn't make any difference, but note on the horizontal, the top of the pipe at 12 o'clock you can't have aeration, And at 6 o'clock, you can have some buildup and some breeze. So anything on the side of the pipe, anything from 1 to 4 o'clock is probably a better location. So here's a picture of the traditional dual traverse where there's both sensors on the same side of the pipe. Again, this is a bird's eye view, so it's not at 12 o'clock, say it's 3 or 9 o'clock. We put the equipment on the pipe, and we get calls all the time that said, up, we're in the middle of the field, can you express out a new chain or a wing nut is busted? And guys and gals, the clamp is hardware. If you're in a pinch, get yourself a tape measure and a zip tie or a hose clamp, and you're still in business. So this is just hardware to make life a little easier, but it's not absolutely required. Remember, the whole purpose of the clamp is to give you a certain amount of spacing. It's a ruler. It's not a micrometer there, so you can get the right spacing to put the transducer in the pipe, and you can do things in a pinch. Here's a picture of the single traverse, so we're going to put the standard clamp on one side of the pipe, and then we're going to put the single transducer on the other side of the pipe. And on a large pipe application, this can actually be lots of fun, because sometimes you can't see the other side of the pipe. So my suggestion is to put the track on one side of the pipe with the ruler and everything, mount it, and then draw a line up to the other side of the pipe and measure 180 degrees, draw another horizontal line, draw a line across the top of the pipe from the starting position of one transducer and put a transducer on the mating side. Now again, this is a math equation. If the pipe is perfectly round, everything is just hokey dokey. But if you're going to put this on a large plastic pipe, they tend to get egg-shaped after a while. So you may actually have to prospect and move the transducer to find the right location. All right, the logger. 100,000 data points, and the first thing you do when you go in the logger, you need to name your file. So come up with a system so when you download data in a week from now, you're not going to forget anything. So go ahead, create your log file. You can use the alphanumeric chart from here. Then you go on and press OK. Now we need to start and set up the log. So here we're going to set up the format type. Recommended to use linear and standard. It's easier to read the log files. And next we're going to set the start and the ending date and times. So in this case there, give yourself a little time, advanced time. Don't say I'm going to start in 10 seconds. So give yourself a little start time, and you can actually practice a log on your desk if you feel uncomfortable with that before you go into the field. So your start time you put down, your end time you put down there, and date. The logging intervals, depending on your application, most people tend to use once a minute. If you log once a minute, you get 1,440 data points in a day. That's fine. That's a lot of data. If you're monitoring toilet flushes, then you might want to go down to the minimum, which is 10-second increments. But it's lots of data, but remember you only have 100,000 data points. And this can be interesting because what if you're collecting different pieces of data? I want to collect totalization. I want to collect flow rate. Maybe you're measuring temperature or BTU. Each one of those counts as an additional data point. So calculate out the number of data points total that you need, and you get started. So on the last step, we use the measurement. We want to select what we want to track. So choose any of the no unit boxes and hit enter. And from there, choose any desired unit that can be replaced or repeated for numerous measurements. So now we can move on. After all settings are input, press activate to begin or queue your log. And now to confirm your meter is being logged, it has a little writing pencil icon in the status bar. That tells you that everything is moving forward here. So to retrieve the data, we have to confirm that the communication option and the menu, meter communications, has been set to the IRDA protocol, and that the IR beam on the PT878 has a clear access to the sensor. Some of the older devices have serial ports, and the newer devices have USB ports. So under Log Manager, highlight the desired log on the left window, press Menu, scroll to the Transfer option, and press Enter. Highlight the desired log in the left window of the Log Manager, press Menu, scroll to the Transfer option, and press Enter. The screen shows a message indicating that the PT878 is searching for an infrared device. Now if it finds a device, it sends another message indicating that it's uploading the log. If it doesn't find the device, well, Our support guy used to work on the Geek Squad. That means you had problems with your computer. So give us a call. We'll see how we can help you out. So again, here's a picture I said of the hardware device itself. You can use what you have. Recommend that you move up from the serial port because Windows just doesn't do a very good job. Any kind of interfacing software, hardware to serial to USB, it will just be an anxiety attack for most people there. So avoid that. Go directly to an infrared device with a USB. You can get it from us. You can get it from anybody. It's not expensive. You need that to really make the device capable. So transfer to the log file, locate the log manager menu, then select your log from the select file, and then you transfer. And in theory, your PC will begin to upload. When the upload is complete, the meter returns to the site manager, and the log file will be transferred to your desktop. And you can open the file on PC using Panlog Viewer or PanaView software and export in Microsoft Excel format. There's an optional thickness gauge you can get for the PT878. In all honesty, overkill in many cases there because the anti-pipe drive book is usually quite sufficient. Fallacy, the thickness gauge itself will measure continuously from the outside of the pipe to the inside of the pipe. It will not pick up anything that's non-metallic. So if you have calcium buildup on the inside of the pipe, if you had ooey gooey gel on the inside of the pipe, it's not going to see that. So it's very good for pipe fatigue monitoring. If you want to go near elbows and look for pipe fatigue, that's the best thing. So not really required. If you use your ANSI pipe chart book, you're all set to go. If you have one, you want to use it. It doesn't require any additional software or firmware. You simply plug the thickness gauge sensor into the upstream downstream inputs that are on the top of the meter itself. It is a hard click, so when you press it in, you'll actually hear a hard click for it to work. And the key too is you get some glycerin to mount it on the outside of the pipe, and make sure you press firmly on the pipe. And you do not use the same acoustic couplant as the transducer, thinner material. And reason being, you can actually pull the sensor back and wick it up and measure the couplant in addition to the pipe wall, so you can get errors with it as well. So from the transducer menu, select Pipe tab and then confirm the appropriate pipe material is selected. And from the Pipe tab, then highlight Measure Wall with the T gauge and then press Enter. As we said, apply the acoustic couplant. In this case, it's a glycerin. You need to press firmly on the pipe or metal or whatever you're measuring it with. And then the PT878 will start displaying measurement in real time. Temperature, temperature, temperature. Very popular all of a sudden. If you were to live in Europe, they're already monitoring your apartment and flat by BTU calculations. In the United States, they're just starting to get their act together. You'll find large facilities, universities, large buildings are actually beginning to monitor their energy compensation in BTU. And the system that you'll see is typical. It's just a closed loop system. We basically have a boiler or a chiller tied into a heat or a cooling load, and it's in a closed loop system. And so basically you only need to monitor flow on one of these loops. And so we put the flow meter on the supply line, and we'll put a temperature sensor on the return supply line and a temperature sensor and return line, and all that data comes back to your meter. And then the meter will calculate BTU. It's pretty neat. But remember, you got to collect all those data points. So in this case there, we got flow is 1, temperature over here is 1, another temperature over there is 3, and then we calculate the BTU. So you're eating up your data points really quick. Now, the kit that you can get, the newer kits, are much more convenient. The older kits, you had a terminal block and all kinds of wires coming out of it. Now, basically, you have some precision strap-on RTDs that go on the outside of the pipe, and we give you some thermal coupling compound. It looks like zinc oxide, real thick, gooey stuff there. And those get plugged into this Y connection, which basically takes the 420 milliamp out of these temperature sensors and runs it right into your I/O port. So there's the hardware. So this is an option that you can get, the energy option for the PT878. And it does eat up the battery. So when you're going to do a BTU calculation, you probably should plug in the meter. for extended use. Now, this is where people make another really big mistake. They said, well, it's BTU, let's throw it on the pipe and we got good data. If you don't do it correctly, you can get bad data. If you're off, 5% on the temperature, you can be off 25% on your BTU calculation. So what you really need to do is take note. You're looking for temperature differential. A clamp-on temperature sensor is not the exact temperature sensor, so we kind of limit it to metal pipe applications. But for location of the sensor, we have to have the left hand and the right hand doing the same, or the supply and the return doing the same. So as you see illustrated, you're not going to mount your RTD on the supply at 12 o'clock and on the return at 6 o'clock. You could have a couple degrees differential on the same pipe if I was to mount a sensor here and a sensor here, because heat rises. So basically what we do is we put the temperature sensor on 3 o'clock on both the devices there to minimize the temperature differential. And that's really all we're looking for, is temperature differential. So this situation here, you can have the best equipment in the world, you got bad data, and you're going to calculate bad data as well. So set up the main screen for temperature, set the measurement screen for reading temperature, and this is done by targeting a box in the main screen and pressing enter. And from there, select the temperature option, then select SEL key to choose what type of temperature option. And so now, before using the temperature features on the PT878, we need to set up the energy and the analog options. So we begin by pressing menu, then select program and press enter. Begin by enabling the energy option. From there, use heating / cooling or supply / return options as necessary. Keep calculations methods on standard. Moving on to the input tab, activate both supply and return inputs A and B, and once finished, confirm with an OK. The second part of the setup involves the analog input menu. Press menu, then choose program, then analog input, press enter. So from here, this confirms that A and B are supply and return temperature, respectively. This is important when you got to go backwards when the guy wants to look at your data. Set the temperature span of both inputs and then hit enter, and now you can monitor temperature. So that was the PT878 GE Panametrics portable ultrasonic transit time flow meter, and a little bit about Instruments Direct. We've been around for a very long time. We've got over 37 years of experience in the world of ultrasonic flow meters. So we are an ultrasonic flow meter engineering company, and we provide a wide variety of ultrasonic flow meters, portable and dedicated, for rental and for sales, of course, serving, and we're just talking about training right now and support. We do some specialty flow meters there, and we provide supplies and support for ultrasonic flow meters such as cables, grease, and if you need to look at an operation manual or software, you'll find them available on our website. So we appreciate your attending our program today. Should you have any additional questions regarding the use of the PT878, feel free to give us a shout or drop us an email. This has been Brent Baird from Instruments Direct. Thank you very much for attending our program today.